Okay, I'm going to explain how Boyer-Moore voting algorithm works. Um, this algorithm allows you to find the majority element in a sequence of objects. Um, so it basically is, if you have a sequence of objects, you, and it, and then you know one of the objects it occurs more than half the time. Like it has n over 2, more than n over 2 copies of itself inside that sequence. You can find it in linear time, also constant space. So the only requirement that you must have is, well, you must have comparison function for these objects, obviously, because otherwise how would you know if something is equal to another thing, right? So that's how you determine if you have copies of yourself. Okay, so it goes like this. You have two variables. One is, I'll call it candidate, which means the candidate for my answer. Okay, and the other one is vote. So it's the vote that candidate has, the current vote. So you initialize it by you to pick the first element. You store it in the candidate variable, and then you increase the vote by 1. So the first iteration, candidate is equal to the first element, and the vote is 1. Second iteration, you check if the second element is same as the first element. So you check if it's same as the candidate. So that's, you compare, and if it's the same, you increase the vote by 1. So your vote would be 2. But if it's not the same, you would decrease the vote by 1. If you decrease the vote by 1 and it becomes a 0, you need to replace the candidate with the replacement. Okay, so you repeat this process until the end, and in the end, whatever object is in that candidate, that would be your majority element of the whole sequence. So why is that true? If you think about it, the only way for that candidate to not be the final answer is if the vote got decreased more than the times that more than the number of copies that object has in the sequence. So in the sequence of objects, if we have more than n over 2, then for that to be replaced, you need to have also more than n over 2 other objects that's different from it. But that's impossible, because that would mean you have how can you have two different objects both with a count of more than n over 2? It adds up not equal to n, it to be more than n. So that cannot happen. Okay, so this is the Boyer-Moore voting algorithm for the case of if you have an object that is more than n over 2.